When we use our one sample z interval to estimate a population proportion p, we can determine that the margin of error will be equal to our z star value times the standard deviation of our statistic. And we can see that when we look at our expression for our confidence interval. We start with our point estimate, or p hat. That's going to be the center. And we get the lower and upper bounds of our confidence interval by adding and subtracting the same quantity. The distance from the center to the endpoints is our margin of error, and since we're adding and subtracting this quantity, that's going to be our margin of error. Now, in the real world, when companies and organizations are trying to conduct a study or they're trying to estimate some proportion, they obviously want to be as precise as possible. So they're usually going to give the researcher some constraint to work with. They're going to say, I want you to figure out this proportion P and be off by no more than 3%. And so it's up to the researcher to conduct a study where they can meet that requirement. And so they have to figure out what value of n, or what sample size they need to have to make sure that they're within that margin of error constraint. And we already intuitively understand that the more people you sample, the more precise estimates you're going to have. It's better to sample 1,000 people versus 100, and it's better to sample 10,000 people versus 1,000. But in the real world, that's not always easy to do. It can be expensive, it could be time consuming. So researchers will usually try to see what's the minimum amount of people that I need to survey or sample to satisfy this margin of error constraint. And so if we're working with this quantity, we just need to basically solve for n. But the issue is that the margin of error also depends on p hat. And that's an issue, and it presents this conundrum. Is well, if we haven't taken the sample, then we're not going to have a value of p hat. And we're not going to take a sample because we need to know how many people we want to sample. So how are we going to get p hat unless we take a number of people to sample? And so it's so what do we do? And so there's usually two methods to go about this. One is to use an educated guess based on previous studies or experience. The other method is to be very conservative and set our p hat to be 0.5. And this is because the margin of error is maximized. It's as large as it can be when p hat is 0.5. So this is the most conservative guess you can get. And I'll show you in another video if you're interested to why this is. But for now, accept it as fact. And so when you're trying to solve for the sample size that will meet our requirements for margin of error, it's essentially solving for this inequality. We're going to make our margin of error greater than or equal to our critical value times the standard deviation of our statistic. Okay, so let's do a practice problem. So suppose that we're trying to estimate the true proportion of students at your school who have a tattoo, and we want to be 95% confident and have a margin of error of no more than 0.1. And so let's go ahead and we're going to set this inequality up. So we need to figure out what z star is, and let's review what that means. If we're looking at a normal curve with 95% or 0.95 area, we're looking for what is the z star value at the lower and upper ends of this. So we're looking for what z star values have an area of not negative, but just 0.025 or 2.5% to each side. Now this can be easily done with a calculator, so I'll show you how to do that. We're going to go to our distribution function, and we're going to use the inverse norm function, and the first number we're going to enter is going to be the area to the left. or 0.025 in this case. And then we're going to enter the mean, which since it's a standard normal curve, our mean will be 0 and our standard deviation will be 1. And this will tell us what our negative z star value will be. And so then that value will be negative 1.96, and this will be 1.96. And we will use our z star value to be a positive quantity because that's usually the norm. So we're going to have 1.96 times the square root of, and we're not told any, sample proportion that we can work with from previous studies, so we're going to just set it to be 0.5. So we're going to have that 0.5 times 1 minus 0.5 in there. Oh, that's weird. Over n. That has to be less than or equal to 0.1, because that's what our margin of error is. And so we got to, make sure we are on top of our algebra. So let me just go through this step by step in case you're a little rusty. We're going to divide both sides by that 1.96. And so we'll get the square root of 0.5 times 0.5 up there, over n, less than or equal to 0.1 over 1.96. We're going to square both sides because that's going to cancel out the square root. And let's just rewrite the 0.5 as 0.5 as 0.25. So we're going to get 0.25 over n is less than or equal to 0.1 over 1.96 squared. And I'm not doing this calculation yet because it's going to give me a decimal approximation, and we don't want to do that yet because we want our final answer to be as precise as possible. And so here we're going to then multiply that side, both sides by n. And if we do that, we'll get 0.25 is less than or equal to this times n. And then we're going to divide by this. So we're going to get 0.25 divided by 0.1 over 1.96, that entire quantity squared. And that's going to be less than or equal to n. So let me just do this in a calculator. It's okay to use your calculator in this class. It's not about calculations. So we're going to have 0.25 divided by, let's do a double parentheses in here. We'll have 0.1 divided by 1.96. That's going to be squared. That's going to be in parentheses, and you're going to get 96.04. Be careful to enter your parentheses correctly. If you're not so confident in this, then just maybe do a couple calculations just to be sure you're correct. But anyways, we're going to get that 96.04 is less than or equal to n. Oh. Now, mathematically, this is our answer, but in the real world, we're not going to have 96.04 people. You can't. And we have to be conservative, so we're going to say that n has to be at least 97. So we would write our answer is that we would need to survey at least 97 students to be 95% confident that we're within 0.1 of the true proportion p. That we are 0.1 of the true proportion p. Proportion p is students who have tattoos at your school.